Pause this video, open up your freezer, and take a big whiff. That smell is instantly recognizable, albeit kind of hard to describe. But here, we're going to do more than describe it. We're going to dig deep into the deep freeze to find out where freezer smell actually comes from and why it's always the same, no matter whose freezer you're sniffing. This is MinuteFood. Freezer smell obviously isn't high on the list of critical culinary quandaries. I really only looked into it out of sheer personal curiosity. But I realized pretty quickly that what's going on here actually makes all sorts of stuff in and out of the kitchen make a lot more sense. And what's going on here is sublimation. You're probably familiar with sublimation's cousin, evaporation, in which a substance goes from a liquid to a gas as molecules on its surface gain enough energy to break free and fly off into the air. Sublimation is when the same thing happens to a solid substance. For lots of solids, like, say, your kitchen counter, it takes so much extra energy for a molecule to break free from its surface under normal everyday conditions that sublimation doesn't happen in any meaningful way, at least on our puny human timescales. But for other solids, breaking away barely takes any extra energy at all. That's why dry ice does this. And still other solids, like these air fresheners, are kind of in between. So sublimation happens, just relatively slowly. Solid water, aka ice, is one of those in-between substances. But at room temperature, water tends to be liquid rather than solid, so there's really no opportunity for sublimation. But in your freezer, where solid water is a thing, it constantly, albeit gradually, sublimates. If you're feeling super nerdy, you can actually observe this for yourself. Just make some ice and weigh it. Then weigh it again after some time in your freezer. My ice initially weighed 266 grams, but just a week later, it weighed only 259 grams. In just a week, nearly 3% of the ice had sublimated away into the air. The very same thing is happening in the food in your freezer. When food freezes, water inside it turns solid. And anywhere that solid water is in contact with the air, it starts sublimating. The first consequence here is that as food loses this moisture to the air, its color and texture change. And we have all seen this before, right? The dreaded freezer burn. Freezer-burned food is just food in which a lot of sublimation has happened. You'll also often see frosty little ice crystals on freezer-burned food because the water that has sublimated away doesn't necessarily stay in the air. Just like how water molecules that evaporate can revert back into liquid water, which we know as condensation, water molecules that sublimate can revert back into solid water in a process called deposition. But something else, something harder to see, is also going on in freezer-burned food. As sublimation happens, it leaves behind little pockets of air where that solid water once was, allowing oxygen to come into more and more contact with the food. And oxygen is kind of a problem child. It is a really reactive molecule that's prone to triggering chemical reactions. These particular chemical reactions, known as oxidation, tend to produce certain types of aroma compounds, ones that are cardboardy, stale, waxy, just generally old smelling. You know the musty smell of old books? And even old people? They come from aroma compounds that are being produced as lignin and skin oxidize over time. And as freezer-burned foods oxidize, the same kinds of compounds give them that characteristic stale smell and taste. Over time, some of these volatile compounds escape the food and end up bumping around in the air. These compounds, and to a lesser extent, aroma compounds from food packaging and the materials that make up the freezer itself, commingle, creating the distinctive smell of your freezer. Of everyone's freezer, actually, because pretty much whatever is in your freezer oxidizing, meats, veggies, nuggets, ice cream, whatever, these same types of compounds with these same types of smells are getting produced. Plus, frozen food packaging and freezer materials are similar enough from freezer to freezer that they too produce a pretty limited range of aromatic compounds. It's a lot like new car smell, another aroma that is both vague and ubiquitous, which is produced as the various materials in a new car's interior off-gas. Although the specifics of those materials might differ a bit from car to car, these materials all tend to send out a similar mix of molecules, one we recognize in totality as new car smell. But new car smell goes away with time as the materials stop off-gassing. Freezer smell only gets worse with time as sublimation and oxidation snowball. And all those stale aroma compounds can actually latch onto other stuff in the freezer. That's why ice that's been in the freezer for a while starts smelling and tasting like, well, freezer. If you want to minimize the grossness associated with sublimation in your freezer, you'll basically need to slow the process down as much as possible. The best way to do that? Keep your food out of contact with the air. Without air, there's no opportunity for those water molecules to break free, and no oxygen around to mess with the food. That's why really well-sealed food doesn't tend to get freezer burn. It's also one reason ice cream manufacturers use those plastic films, which you can replicate at home with parchment or plastic wrap. And it's why frozen seafood is sometimes entombed in a thin layer of ice, a technique known as glazing. Anything that keeps air away from the surface of frozen food will protect it from the not-so-nice effects of sublimation. But sublimation doesn't always ruin food. Just look at freeze drying. Freeze dryers work by first freezing the food, turning the water inside it into ice. Then the pressure in the chamber gets turned way down, and a bit of heat is added. Conditions which make it way easier for water molecules to break free from the surface and fly into the air. In anywhere from a few hours to a few days, basically all the water in the food has sublimated away. This creates some clever advantages. Since there's very little heat involved in the processing, the food is preserved basically as is, just without water. And without water, freeze-dried food is super shelf-stable. It can last for decades. Like food in the freezer that's undergoing sublimation, freeze-dried food is subject to oxidation. But since the freeze-drying process itself is so fast, there's not that much opportunity for oxidation to happen during it. And after freeze-drying, foods are generally vacuum-sealed or stored with these little oxidant absorbers to limit oxidation. Plus, sublimation leaves behind all those air pockets, producing the porous texture that is critical to the deliciousness of freeze-dried ice cream and fruit and candy. Freeze-drying is basically a way that we have taken the weird process of sublimation and optimized it. You could say it's a pretty sublime idea. But you know what's way more sublime? Our amazing patrons. If you want to support what we do and get fun stuff like printables, behind-the-scenes access, and discounts on MinuteFood merch, join our community over on Patreon or right here with YouTube memberships. As always, thank you.